Reviewing lessons 2.6 through 2.10 on page 155. Lesson 2.6 is on ratios, rates, and conversions. One of the big things we talked about in this section was on converting units. So if you look at number 40, we've got 2.25 miles and they want us to convert that into yards. So since there's only one unit here is miles, the 2.25 miles we can just put over 1. And then we can multiply by a conversion factor. In order to get the miles to cancel, we want it to be in the opposite part of the fraction. So since this miles that we have is in the numerator, on our conversion factor we want it to be in the denominator, so those will cancel. So the miles we're going to try and transfer into yards. So if you look at the reference sheet, 1 mile is 1,760 yards. So at that point the miles cancel out. If you multiply straight across, then you should get 3,960 yards. That'll be over 1. Divide by 1 doesn't change it, so 3,960 yards is our answer. Something else they can have us do is do a conversion where we have 2 units and maybe both of them need to be changed. So if you have 30 feet per second, that's 30 feet in 1 second, and we're trying to change this into miles per hour. So miles per hour, there's a couple ways we can do this. So one thing we could look at is we could change the feet into miles. So to get the feet to cancel, it needs to be in the other part of the fraction. So the one we have now is in the numerator, so this would have to be in the denominator. And our conversion is 1 mile is 5,280 feet. So by doing that, the feet will cancel out. And it's up to you. If you want to go ahead and do your other conversions right away, you can. If not, you can just go ahead and get this figured out. So this would be 30 miles over 5,280 seconds. And usually I'll just go ahead and leave that alone for the time being. So we have miles per second, we want miles per hour. So we need to change the seconds. To get rid of the seconds, we need to put it in the opposite part of the fraction. So this would be in the numerator this time. The seconds, if you want to change to minutes. If you want to figure out how many seconds are in an hour, you can do a direct conversion that way if you want. So 1 minute is 60 seconds. So then the seconds cancel out. So that would be 1,800 miles over 5,280 minutes. So that's miles per minute. We want miles per hour. So minutes needs to go in the numerator to cancel it. We're changing it to hours. 1 hour is equal to 60 minutes. If you multiply that out, is 108,000 miles over 5,280 hours. And then if you divide that out, let's say they want us to go to the nearest tenth. This would be about 20.5 miles per hour. It's 4 or 5 keeps repeating, so it'd be 45/99, which is 20 and 5/11 if you wanted an exact answer, but we'll just say nearest tenth, so 20.5 miles per hour. Another similar problem, let's say we have feet per minute, we're going to kilometers per second. What's different on this problem is we're actually going to a different system of measurement. So feet is the customary system, we're going to kilometers, which is in the metric system. So first of all, probably an easier conversion would be to convert minutes to seconds. So 1 minute is 60 seconds. And again, you can reduce that down if you want, or you can just leave it alone for now. So 50 feet in 60 seconds. So the feet we need to change to kilometers. So one of the conversions on your reference sheet in your book is converting feet to meters. So 1 foot is 305 thousandths of a meter. That'll get the feet to cancel out. And if you multiply that as 15.25 meters per 60 seconds. Ultimately, we don't want meters, we want kilometers, so get rid of the meters by putting it in the opposite part of the fraction. 1 kilometer is equal to 1,000 meters. So 15.25 kilometers per 60,000 seconds. And if you divide it out, it comes out really small number, 0.000254116 repeating. Potentially, if you use a different conversion, let's say you changed the feet to miles and then the miles to kilometers, since those conversions are rounded off, there's not a nice, easy conversion between metric and customary systems. Your answer might have come out slightly different than that, but it should still be pretty close. And this one probably would be best to not round to the nearest tenth, because nearest tenth we would just say it's 0, but anyway, so we'll just call that our answer for that problem. One more conversion problem we'll look at here. I'm not sure why we would be doing this conversion, but anyway, let's say we have 5 liters per meter, and we're trying to change it into quarts per inch. So in this one, both of these are in the wrong system of measurement. Liters and meters are both metric systems measurements, and quarts and inches are both customary system measurements. So one of the things we can do if we look at our conversions between the customary and metric units, we can look for a conversion from liters to quarts or quarts to liters. And first of all, let's figure out where these go. Liters needs to go in the denominator so it can cancel out. So 1 quart is 946 thousandths of a liter. So that will get the liters to cancel out. So that's quarts per meter. We want quarts per inch. So we want to get rid of the meters and ideally go to inches, but we might have to do another conversion in between there. There's a conversion with feet and meters, so we'll use that one. So 1 foot is 305 thousandths of a meter. So that gets our meters to cancel out. So that's quarts per foot. We want quarts per inch, so we'll finish off. 1 foot is 12 inches. So 1.525 quarts over 11.352 inches. And then if you divide that out, it's about 0.134337562 quarts per inch. Okay, and again, it would be a matter of, maybe they say the nearest hundredth would be 13 hundredths of a quart per inch. Okay, so biggest thing with these conversions, just really watch and make sure you're putting the right numbers in the right spots and make sure you're looking at the right conversion. Sections 7 and 8 are on solving proportions and using similar figures. So if you look at number 46, they want us to solve this proportion. So if we're trying to solve this, one thing we can try to do is look for a pattern going towards the variable. So maybe we'll try to go from 15 to 4 and see if that's a pattern. Or we could go from 15 to 6 and see if that's a pattern. If I don't have a calculator, neither one really are that appealing to me. I don't really see an obvious pattern. So since the variable is in the numerator, we could just say it's being divided by 4, so we can multiply by 4 on both sides. And that would be 24 over 15. Both of those we can reduce by 3, which would be 8/5 or 1 3/5. So that didn't come out real great if we were trying to do a conversion between those. If you did it as a decimal, you could do 1 6/10 would work also. If you ever had a problem like that where you didn't have a calculator and the variable was in the denominator, what you could do is just take reciprocals on both sides. So, like if I had 3 over 7 equals 5 over x, you can just do reciprocals and change it to 7/3 equals x over 5. Okay, it's kind of like ratios. If we got a ratio of apples to oranges and we change it around to oranges to apples, it's kind of that idea. Okay, as long as we do the same thing on both sides, we're allowed to do that. So next, we'll look at number 48. What's different on 48 is that we have 2 variables. We have the same letter, but it's in 2 different places in the problem. So on a problem like this, it is best probably just to cross multiply. And again, cross multiplying basically is multiplying the denominators together and then multiplying by that number on both sides is why it works. So this is what we're doing with cross multiplying here. It's basically as if we were multiplying both sides of the equation by 42. Somebody just figured this out as a kind of a shortcut, I guess you'd say. So 6 times the quantity b plus 3 equals 7 times the quantity b minus 3. We can go ahead and distribute. Make sure you distribute to everything inside the parentheses. So 6b plus 18 equals 7b minus 21. Then we can go ahead and get our variable on one side. If you'd like a positive coefficient, you could subtract 6b on both sides. And then finally they're subtracting 21. You could add 21 on both sides. That's a 1b, which is the same as b. So b equals 39. Again, on these problems, any of these problems, if you have time, if you've got like an extra minute or something, you can substitute that back into the original problem and see if it works. So if we do this, 39 plus 3 is 42 over 7, and 36 over 6 on the other side. 42 divided by 7 is 6, 36 divided by 6 is 6, and those are equal, so we know we've got the right answer. So those are some examples with proportions. We can also look here at number 51, which is dealing with similar figures. So on 51, you project a drawing 7 inches wide and 4.5 inches tall onto a wall. The projected image is 27 inches tall, and the question is, how wide is the projected image? So what we can do is look at the information here. We're trying to figure out the width of the projection. So it's up to you how you want to do this. I'm just going to start with what I'm trying to find, which is the width of the projected image. And then we also have the drawing. So the width of the drawing is 7 inches. And then we'll just do a proportion here. So the projection for the length, or the height, I should say, the projected height is 27 inches. And the drawing height is 4.5 inches. I'll just put it as 4.5 inches since the decimal is nice. And again, this just depends if you have a calculator or if you're able to see this really well. Otherwise, you could just multiply by 7 on both sides. This happens to be, if you did 27 divided by 4.5, you would get 6. And if we go towards the variable, then that would be multiplying because the number is getting bigger. So multiplying by 6. If we multiply by 6 on the other side, that would be 42 inches. So basically what we're saying is the projection is 6 times bigger than the drawing is. Section 9 is on percents. And so we talked about in this section the percent proportion. And we also talked about the percent equation. Those were a couple of things we talked about. So if we look at number 52. So the question is, what percent of 37 is 111? So again, it's up to you how you want to do these. My preference is percent equation, but you can do proportion also if you want. So I'm just going to do what percent, so that's what we're trying to find. So if you want to do P for percent, you can, or if you want to do X percent, just to remind yourself that you're finding the percent here. Of means multiply. 37 comes on down. Is means equals. And 111 means 111. At this point, we're trying to get the variable by itself. They're multiplying, so we can divide by 37 on both sides. These numbers don't look real great, but actually if you divide 111 by 37, you'll get 3. That is not a percent. That's as a decimal, so we need to move the decimal 2 spots to the right. Add some zeros, and that means 300%. And then if we put that back in the problem and see if that makes sense, 300% of 37 is 111. Okay, that seems reasonable. If you do 300% of something, means it's 3 times bigger than what it was before. If we look at number 53, what is 72% of 150? If you want to, you can say this is what we're trying to find. So x equals percent, we can change to a decimal. 72 hundredths of means times 150. In this case, the x is by itself, so it's just a matter of multiplying those two together. And that should come out as 108. And what that means, if you put this back in here, we're saying 108 is 72% of 150. Again, seems like a reasonable answer. If we look at number 54, 60% of what number? So 60% we can change to a decimal. You don't have to put the 0 at the end if you don't want to. Of is multiplying. What number? That's what we're trying to find. Is means equals 102. And on this one, we're trying to get the variable by itself, so we could say it's being multiplied, so we can divide on both sides by 6/10 or 60 hundredths. We're dividing by a number less than 1, so our answer is going to get bigger here. And so that would be 170. So we're saying 60% of 170 is 102. One other thing we did in this section was we talked about the interest formula. I equals PRT. I was the interest, P was the principal, which is the amount of money we invested or borrowed. R is the interest rate as a decimal, and T is the time in years. So there's 4 variables here. As long as they give us 3 out of the 4, we can find the 4th one. Section 10, we're looking at whether we have a percent increase or decrease and rounding to the nearest percent. So if we look at 58, the original amount was 27 and the new amount was 30. So percent change, we're finding the change divided by the original. How much did it change compared to what it was? So for the change, we can subtract, just take the bigger number minus the smaller number. And the original number was 27. So 30 minus 27 is 3. And 3 divided by 27. They want us to round these to the nearest percent. So this comes out to like 11.1 repeating. So to the nearest percent, that would be 11%. If we look at number 60, another percent change problem. So the original amount was 873, the new amount was 781. So we find the change by subtracting those. Divided by the original was 873. So if you subtract those, would be 92 over 873. And then if you divide that out, is 0.1053 something. Move your decimal 2 spots, and then if we go to the nearest percent, that would be about 11%. Also on these, I forgot on the last one, they wanted us to tell whether it was an increase or decrease. So this one was 873, now it's 781, so it went down, so that was a decrease. The previous problem went from 27 to 30, it went up, so that would have been increase. So last one was 11% increase, this one is 11% decrease. So this gives you an idea of some of the things that we did in lessons 2.6 through 2.10.